Assalamu alaikum. I'm Hamza from Mechatronics Department of Air University. So today we are going to design a 4-bit combinational circuit by using a 4-bit binary adder. So this problem is categorized into two parts, the first stage and the second stage. So for the first stage, the logic is that if there is an even number, the circuit should add 1 to it, and on the output an odd number should be displayed. Moreover, for the second stage, the requirement is that the circuit should retain the value that is given as an input to the first stage. Whether it's even or odd, the circuit should retain that value. Like if we have 0, 1, which is 2, then for the output of the first stage it should be 1, 1, which is 3, and for the output of the second stage it should be 1, 0, which is again 2. So for the even number, first stage add 1 to it, and at the output we have an odd number, but the second stage retain the value whether it's even or odd. Similarly, if we have an input of 3, i.e. 1, 1, so the first stage retain that value because there is a requirement for the first stage that for even number it just add 1, but for the odd number it retain the value. Moreover, for the second stage again, whether it's even or odd, it should retain the value, so it hold the odd number. Now we come to the circuit designing process on Proteus. So on Proteus we are using a keypad and 4 mux. Again we are using 4 mux so that the input from the keypad should be accurate, and it does not give dots or any other value. And by the input from the keypad we have 4008, an adder IC. So this adder IC is used to give the input for the first stage, and then the second stage. So if we have enter an even number from the keypad, like we have entered 2, at A1 of 4008 IC we come up with 0, and then there is a NOT gate which invert the 0, so we come up with 1, and then it adds up. So in this way, 1 plus 0 we come up with 1, and an odd number is displayed for the first stage. But for the second stage we are using an AND gate. So for the AND gate, if we have entered an even number, so at A1 we come up with 0, and for B1 we come up with 1 as we are using an NOT gate. But for the AND gate we are using from the second stage, its first input is from A1 and its second input is the output of the adder. So again we come up with 0. In this way the AND gate works, and the second stage retains the original value. So if we enter an odd number from the keypad, like if we enter 3, so we come up with 1 for A1 and 0 for B1, and again we come up with 3 for the first stage as the first stage retain the odd value, and the second stage also retain the value whether it's even or odd, as we're using AND gate, and the logic for AND gate is it performs the multiplication operation as it is dot. So in this way our circuit works. So it's all about question number 2. Thank you.